Hello and welcome to helpyourmath.com. In this video, we are going to examine the transformations of absolute value functions. Now we're not actually going to graph, we're just going to analyze what happens when we move an absolute value function around in the coordinate plane. Before we get to that, let's just review what is an absolute value function. So here's its graph. You'll notice that it's a V shape, so absolute value, V shape. The parent function for the absolute value is f of x is equal to the absolute value of x. So whatever you plug in, you take its absolute value, and that's how you get the output. It's symmetric about a vertical line containing a point called the vertex of the graph. So the vertex here is 0, 0. And I use the vertex a lot. When I'm looking for transformations, I always try to seek out what the vertex is and kind of use the other transformations from there because everything's symmetric about it. So if we draw the vertical line, x is equal to 0, we can see that if we folded this graph, it would be symmetric about that line. How does that help us? Well, because I know if I go 1 unit to the right, I'll have the same value as if I go 1 unit to the left. So I go to the right 1 and up 1, and I have that point 1, 1. I can do that same thing on the left, go 1 unit to the left, go up 1, and I'm going to find another point on the graph, negative 1, 1. And that's going to be true for all the values around that vertex. So what are we looking for when we're talking about transformations? We look for 3 main types. We're looking for vertical or horizontal shifts, so that's moving up or down in the plane or to the left and right. Reflection about the x-axis. There are also reflections about the y-axis, but in this case, you wouldn't see a reflection because it would just be itself, right? If you were to reflect this about the y-axis, it would just be the thing itself. And we look for non-rigid transformations, such as vertical stretches or shrinks. Let's get started. So we want to state the parent function. This whole video is about absolute value functions, so every parent function will be the same here. And then we're going to describe each transformation. So first, the parent function. The parent function is, what's the parent function for that absolute value? That would be f of x is equal to the absolute value of x. Next, we're going to look for those 3 things. So first, where's the vertex on this graph? The vertex is over here at 3, 0. So remember for the parent function, it was at 0, 0. This indicates to us that there is a horizontal shift to the right. There is a horizontal shift of 3 units to the right. And that's it. So it's still facing up, so we know that there's not a reflection about the x-axis. And the other thing we would look for are the non-rigid transformations. If there was a non-rigid transformation, that's a stretch or a shrink, then it would do something different than go to the right or left one and up one. And what I see here is that we go over 1, up 1, over 1, up 1. That indicates to me there's no non-rigid transformation. Okay, how about this one here? So this one here, we all know the parent function, right? Say it with me. The parent function is f of x is equal to the absolute value of x. It's the absolute value of x. Okay, and then what else happened here? So remember that vertex on the parent function should have been at 0, 0. I see it's up here at 0, 2. So this indicates to us that we had a vertical shift of 2 units up, or up 2 units, however you want to say that. The next thing we want to look for, it's a V opening up, so we know that there's not a reflection. And the last thing we would look for is the non-rigid transformation. And again, the way we judge that is if we go over 1 and up 1 and don't hit a point on the graph, then there's a non-rigid transformation. So starting at the vertex, if I go over 1, up 1, I hit the graph again. That indicates no non-rigid transformations. So the only thing that happened here was there is a vertical shift up 2 units. Okay, how about this one here? So this one here, the parent function, again, you can say it with me. It's f of x is equal to the absolute value of x. We know that this is the case because it's that V shape. Let's see, I see the vertex is all the way down here, and it's at 1, negative 1, 2, 3, negative 3. Okay, so that's our new vertex. So what this indicates to me is that we've shifted to the right. There is a horizontal transformation, or a horizontal shift, I should say, a horizontal shift. And we can just say 1 unit to the right. And the graph also went down, right? The vertex should be up here. It also went down 3 units. There was a vertical shift. and that is 3 units down. I see it's opening up, which indicates there's no reflection. And the last thing we want to look for are those non-rigid transformations. How do we know if there's a non-rigid transformation? That means that if we start at the vertex and go over one, up one, we don't hit the graph. Since we do hit the graph, there are no non-rigid transformations. So the only two was there was a horizontal shift and a vertical shift on this graph. How about this one here? Okay, it looks like we have a few things going on here, but first we're going to state the parent function. The parent function is f of x is equal to absolute value of x. Ooh, I almost put a parenthesis there. Now I kind of like half-hearted did. Okay, but it shouldn't be a parenthesis, it should be absolute value. Okay, next. Oh, I noticed the v is upside down. So what does that tell us? There is a reflection about the x-axis. So we know there's a reflection about the x-axis. And what else? Well, I noticed the vertex should be at 0, 0, and it's not at 0, 0. Where is it now? It's at -5, +4. Okay, so this indicates to me that there is a horizontal shift. And the horizontal shift, it went over 5 units to the left, so left 5 units. And what else happened? There's a vertical shift. And the vertical shift, it is up 4 units. Up 4 units. Okay, the last thing we want to check for are those non-rigid transformations. If I go, in this case, because it's reflected, now I'm going to go down 1 over 1 to see if there's another point there. I go down 1 over 1, I found a point that indicates to me there's no non-rigid transformation. These have been examples of describing the transformations of absolute value functions. Thank you for stopping by.